Hello friends, my name is Amardeep Singh. In this file, I'm going to be talking about a very important functionality in Excel, which is called goal seek functionality. Now, in order to discuss this functionality, I'll walk you through with a small case. In this case, let us imagine that you have won a lottery and that is two options attached to it. Option number one is that you can take $10 million immediately, and option number two is that you can receive $1 million amount every year for next 15 years. And the catch here is that the first $1 million amount will be given to you immediately and the subsequent payments will happen at annual intervals. Alright, now here comes another principle, which is the present value concept, because $1 million that you would receive after 1 year will not be worth $1 million as of today. So whatever annuity payment of $1 million that you will receive for the next 15 years, that will have to be discounted to be able to arrive at the present value, so that we can compare it to the first option value of $10 million. Now let's imagine a situation that, or just assume that the present value, the sum of the present value of the 15 payments that you would receive for the next 15 years comes out to be $9 million. So effectively what's going to happen, that there would be a difference of $1 million between option number 1 and option number 2. So what we need to do as a next step is we would need to find out that if instead of receiving $1 million annuity amount every year for 15 years, we were to pay an additional amount, what that additional amount should be. Alright, let's take an example, or let's assume that it's going to be $100,000. So effectively what we would need to do is we would need to add that $100,000 to the initial amount of $1 million. So effectively each year the person will receive $1.1 million for next 15 years, so that both the options break even. Alright, so for the time being, to start with, let us assume that the additional amount to be received is nil, so that we are able to do the comparison and find out whether option number 1 is beneficial or option number 2 is beneficial. So over here what will happen, we will receive an annuity amount for next 15 years. So I've plotted the period out here starting from 0 up to 14. The reason for that is the first payment is being made immediately. So if the first payment is made immediately, effectively that is being received as of today itself. So there is no need to actually discount it to the present value. That is why I've started with a period of 0 instead of starting with 1. Alright, so the annual amount that we would receive is going to be equal to $1 million that I've mentioned in cell B8. Let us fix that amount plus additional amount to be received, which is nil for the time being. Again, I would fix it because we have to copy and paste this formula down in all of these 15 cells. Alright, so we are going to be receiving $1 million plus 0, which makes it $1 million each year, and the absolute summation of these 15 numbers would be 15 million. Now obviously this 15 million cannot be straight away compared to a one-time payment option of 10 million. That is why, as I said earlier, we would need to use a discounting factor, and we would need to multiply that discounting factor with the annual amount that we are receiving, so that we are able to find out the present value of each of these annuity payments. And then at the end we would need to find out what is the total present value. Alright, now how do you compute the discounting factor? Discounting factor can be computed by using the concept of time value of money, wherein we take this factor as equal to 1 divided by 1 plus the discount rate raised to the power n, wherein n is the period for which the discounting has to happen. Alright, over here we already have the period mentioned in the first column, so we can compute the discounting factor here as 1 divided by 1 plus discounting rate, which we need to assume as 8% in this example. Let us fix that, raised to the power period, which is given in the first column. Alright, now obviously the first one is already the present period, so it's going to give us the discounting factor as 1, and as you would move further you would see that the discounting factor keeps on reducing. Right, so if we were to interpret each of these discounting factor, it would mean that a dollar after 14 years would be worth $0.34 as of today. So effectively, if I'm going to receive $1 million after 14 years, which is in the 15th year, I'm going to be receiving it in the beginning, so effectively I'll have to discount it for 14 years. So that $1 million will be worth $1 million multiplied by 0.34 which is approximately 0.34 million as of today. So if you were to find out the total present value of all of these absolute amounts, then we would need to individually take these amount from this particular column and multiply that with discounting factor. So I can either add one more column here to be able to find out the present value, or I can straight away use a function which is sum product, and sum product can take the array number 1 from here and comma array number 2 from here, which has got the discounting factor. So effectively the individual values from these two arrays would be picked and multiplied, and finally they would be added together to give us this total sum, which is $9.2 million in this case. Now you can compare that in option number 1 we are receiving $10 million, and in option number 2 the annuity that we are receiving for the next 15 years translates to a total present value of 9.2 million as of today. So effectively we are better off going with option number 1, because option number 1 gives us a higher amount to the tune of about $755,000. Alright, so option number 1 is better. If we go by $1 million annuity for next 15 years versus a 10 million, then option number 1, which gives us the one-time payment, is better. Now the next question is that what should be the additional annual amount to be received so that both options break even. Now in this example we are very clear on one fact, that $1 million is not sufficient to be received for next 15 years, because that gives us a total present value of 9.2 million, and that is less than 10. Right? So if we were to actually make both the options break even, then we would need to receive some additional amount. Now what that additional amount should be, I don't know. Let me just put some random number. Let me just put 50,000 here. So if I put 50,000, what happens is this $9.2 million increases to 9.7 million, because here we are saying that instead of receiving $1 million each year, we would receive $1 million plus 50,000. But still this option gives us a lesser amount as compared to 10 million, so we would need to increase it a little further. So let me just increase it to 80,000. If I increase it to 80,000, it gives me 9.98, so we are pretty close. But still this is giving us a lesser amount, so we need to increase it further. So let's say instead of receiving 80,000, I make it 90,000. But when I make it 90,000, you see that this amount has now crossed 10 million. So this gives us an indication that the final answer should be between 80,000 to 90,000. But what that amount would be, right now we are just using hit and trial, just to be able to make sure that both the options break even. Or in simple terms, if I were to say that when would these options break even? These options would break even when the difference is going to be nil. So both options would break even when the difference is equal to nil. Now I don't know what that amount would be, because right now I'm just using the hit and trial method to be able to make it 0. Right? And we might actually end up doing this hit and trial for about 10-15 times, and probably we would be able to get an answer which gives us a difference which is very close to 0. But we might never get an answer by using hit and trial method which gives us exactly 0. So what we can do in this case is we can use a functionality which is called goal seek. So basically goal seek functionality is used in Excel when you have a target result to be achieved. Now in this case the target result is the difference needs to be made equal to 0. And how would you make it equal to 0? By changing an input cell. And what is that input cell? This one, which is additional amount to be received. Alright, so instead of doing this by using hit and trial, we can just reinstate the original value of 0 out here. So I've again put a 0 value here, and now I'm going to be using the goal seek functionality, wherein I would say that we need to set this difference value to a nil value by changing this cell. Alright, so let's go to goal seek functionality that you would find in data tab. Click on data tab in the ribbon. On the right hand side you would see something called as a what if analysis. Under what if analysis you would see there are 3 options, and right now we are talking about goal seek. So as you can see, it mentions that goal seek is used to find the right input for the value you want. Alright, so we need to find out the right input in terms of the additional amount to be received. And what is the value that we want? We want the difference amount to be equal to 0. So I would click on goal seek. It will open this pop-up window. which would have three parameters. The first parameter is set cell. Which cell do you want to set? What is your target cell? My target cell is the difference cell, which is F15. The next is to a value. What do you want to set it to? I want to set cell F15 to a value of 0. So I would put 0 out here. And by changing cell, which cell do you want to change? I want to change the cell F17. Then press OK. You would see it would run certain iterations. You are able to see it out here that it is running certain iterations, and then it says that the goal seeking with the cell F15 found a solution. The target value was 0 and the current value is also 0. If you want to accept this solution, press OK. If you do not want to accept this solution, press cancel. So in this case I would press OK, and now you can see that if the additional amount to be received is 81,755, then the present value of those 15 amounts that you would receive in the next 15 years would be exactly equal to 10 million, and the difference would be 0. So here you can see that we don't have to actually resort to the hit and trial. Excel can automatically run those iterations in the back end for us, and it will give us a result if obviously it is doable. Like in this case, when I was doing the hit and trial, I was able to find out that the number in this cell should be between 80,000 to 90,000, and Excel is also given a number which is between this. Alright, so just to summarize, we typically use goal seek functionality when we have to receive or when we have to achieve a desired output by changing a single input. In this case, that desired output was the difference cell, and that desired output was to be made equal to 0, and the input cell which had to be changed in this case was the additional amount to be received. Alright, so I hope the goal seek functionality is clear to all of you, and you're able to also understand that in what all situations we use goal seek functionality. Thank you very much, and stay tuned for further videos. Bye bye.